In this video, we'll be diving into SQL subqueries. Subqueries are a powerful tool in SQL that allows you to nest queries within each other, opening up a world of possibilities for data retrieval and manipulation. Let's explore how to use them effectively. This video is about nesting queries within queries. So, what exactly are SQL subqueries? A subquery is essentially a SQL query that is nested inside another query. Think of it as a query within a query. This nesting allows you to use the results of one query as part of another query's conditions or operations. In other words, the inner query computes something, and the outer query uses that result. Here's an example. The outer query is selecting all information from the employees table, where the department ID is in the result of the subquery. The subquery selects the department ID from the departments table, where the budget is greater than 100,000. SQL subqueries come in a few different flavors. First, we have single-row subqueries. These return only one row of data and are used with single-row comparison operators like equals, greater than, or equals to, less than or equals to, and not equals to. As an example, this query selects the name from the employees table where the salary is greater than the average salary from the employees table. Next up are multiple row subqueries. These return multiple rows and are used with operators like in, any, and all to compare values against multiple results. Here is an example, which selects the name from the employees table where the department ID is in the result of selecting the ID from the departments table where the location is New York City. Finally, we have correlated subqueries. These reference one or more columns from the outer query and are executed once for each row processed by the outer query. Here's an example where we select the employee name from the employees table, where the salary is greater than the average salary from the employees table, but only for the same department. Now let's break down the syntax and structure of SQL subqueries. The basic syntax involves a main query that contains a subquery within it. The subquery is typically enclosed in parentheses. The outer query uses the result of the subquery to filter or manipulate data. The subquery is embedded within the outer query, usually in the where clause. The common placements of subqueries are in the where clause, from clause, and the select clause. Consider this main query box where we select column 1, column 2 from the table name where the column name operator, and then parentheses around the subquery which is select column from the table. There is an arrow which indicates that the subquery is nested inside the main query. One common use case for subqueries is in the where clause. This allows you to filter the results of the main query based on the results of the subquery. First, let's see an example using comparison operators. Here we want to find employees earning more than average. This query selects the employee ID, last name, and salary from the employees table where the salary is greater than the average of the salary from the employees table, and it is ordered by salary. This subquery first calculates the average salary. Then, the main query finds all employees with salaries greater than that average. Next, let's see an example using the in operator. Here we want to find employees in specific departments. This query selects the employee ID, first name, and last name from the employees table where the department ID is in the result of the subquery to select the department ID from the departments table where the location ID equals 1,700. The subquery returns a list of department IDs in a specific location. The main query then finds all employees working in those departments. Another powerful use of subqueries is in the from clause. When a subquery is used in the from clause, it creates a temporary virtual table that exists only for the duration of the query. This temporary table is called a derived table or inline view and must be given an alias. Let's see an example of department salary statistics. This query selects the department name, average salary, minimum salary, and maximum salary from the departments table, joining the result of this subquery on the department ID. The subquery is selecting the department ID, the average salary as average salary, the minimum salary as minimum salary, and the maximum salary as maximum salary from the employees table, grouped by department ID and ordered by the department name. This query creates a derived table with salary statistics per department, joins it with the departments table, and shows each department's name with its salary statistics. You can also use subqueries in the Select clause to retrieve computed values alongside other columns. These subqueries are called scalar subqueries and must return exactly one value. For each employee, this query retrieves their department name using a subquery in the Select clause. Here we select the employee ID, first name department ID, and the result of the subquery as department name from the employees table, ordered by employee ID. The subquery is selecting the department name from the departments table, where the department ID equals the employee's department ID. The subquery is run once for each row in the employees table. It's a correlated subquery. Here's a comparison with using a join. This produces the same result as the scalar subquery example, but often with better performance. Here we select the employee ID, first name department ID, and department name from the employees table, joining the departments table on the department ID, and order by employee ID. As a best practice, use joins when possible, but subqueries can be more readable for complex operations, or when you need to show computation steps. Let's take a closer look at correlated subqueries. A correlated subquery is a subquery that references columns from the outer query and is executed once for each row processed by the outer query. Unlike regular subqueries, which are executed once before the main query, correlated subqueries are dependent on the outer query and cannot be run independently. First, let's look at an example of finding employees with above-average department salary. We select the employee ID, first name, last name, salary, and department ID from the employees table where the salary is greater than the average salary from the employees table, where the department ID equals the employee's department ID, ordered by the employee's department ID. For each employee, this query compares their salary to the average salary within their specific department. Now let's look at using the exists keyword with correlated subqueries. We select the department ID and department name from the departments table where exists, and then a subquery, which selects one from the employees table where the employee's department ID equals the department's department ID, and the employee's salary is greater than 10,000, ordered by the department name. This query finds departments that have at least one employee with a salary greater than 10,000. When working with subqueries, it's important to consider performance implications. Correlated subqueries can be expensive, as they run once per outer row. Avoid unnecessary subqueries. Joins are often more efficient for retrieving related data. Ensure proper indexing on columns used in join conditions between the main query and the subquery. Use exists instead of in for large result sets when checking for existence only. Consider using common table expressions, or CTEs, for better readability and optimization. When possible, consider using joins instead of subqueries. Here's an example of a subquery version to select the employee ID and last name from the employees table, where the department ID is in the subquery to select the department ID from the departments table, where the location ID equals 1700. An alternative version using joins is to select the employee ID and last name from the employees table, joining the departments table on the department ID where the location ID is 1700. However, subqueries are valuable when you need to perform aggregations before joining, you need a more complex filtering logic, or you want to make the query more readable. Let's wrap up with some best practices and a summary of what we've covered. Key points about subqueries are that they are queries nested within other queries. They can be used in select, from, and where clauses. There are single row, multiple row, and correlated types. Correlated subqueries reference outer query columns. They can be used with operators like equals, in, exists, etc. Performance varies and joins are often more efficient, and proper indexing is crucial for performance. Some best practices are to use meaningful aliases for clarity, consider performance implications of nested subqueries, use joins instead of subqueries when appropriate, test complex queries with explain plan, and keep subqueries focused and simple. For example, always consider readability. Here is an example using common table expressions or CTEs to calculate the average department salary. Then we join the employees table with the average department salary table on the department ID, where the employee salary is greater than the average salary. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.